Hello again. We are now on lesson 2.2b. The B's are kind of like a little side note of things we'd like to discuss in addition to the regular 2.2 lesson. And the topic is slopes of parallel and perpendicular lines. So first off, we're going to talk about parallel lines because I think that's the one that you're most comfortable with. We all remember that parallel lines are lines that will never cross or touch. We say that they'll never intersect. That's fancy for they're never going to cross. And basically, if you see two vertical lines, those are parallel to one another. They're never going to cross. And two horizontal lines, those won't cross either, unless they're the same exact line. So the other lines, the way you can tell that they are parallel, is that they're going to have the same slope. Because remember, slope means steepness. So lines that share the same exact steepness will never cross. They'll never intersect, and they are parallel. So I give you an example here, and I have a whole bunch of graphs, and I ask you which lines, if any, are parallel to one another. So there are 3 lines here. And basically I told you, if the lines have the same exact slope, they're parallel. In looking at those 3, you might think, well, all 3 of them look like they're parallel. But I don't just ask you which look like they're parallel, I ask you to prove your answer of which ones are. So the proof here that they're parallel would mean that they have the same slope. Do you remember how to find the slope of a line? It's as easy as rise over run. So what we're going to do, and what you would do if given a problem like this with graphs asking which ones are parallel, you'll find the slope of each one, and the ones that have the same slope, those are parallel. So look at line number 1. To get from one point to the next in line number 1, you would go up 1, 2, 3, 4, and right 1. That means its slope is 4 over 1, or 4. To find the slope of line 2 going from point to point, you would go up 1, 2, 3, 4, 5, right 1. So the slope of that one is 5. So I already know 1 and 2 are not parallel. They have 2 different slopes. So let's see which one line 3 is parallel to. 1, 2, 3, 4, right 1. So 4 over 1 means 4. So to answer this question, you would say, which 2 lines are parallel? Lines 1 and 3 are parallel. And we're supposed to justify or prove our answer. And how did we prove it? They both have a slope of 4. All right, so that's how you can prove it. And again, you can't just look at it. You have to prove it. So sometimes I'll give you some statements in words and ask you, hey, are these parallel or not? And this will go with the opening paragraph. I had told you that if you have 2 vertical lines, they're parallel, and 2 horizontal lines are parallel. So if given y equals 3 and y equals 5, and answering the question, are these parallel or not, you need to recall that y equals 3 and y equals 5 are both horizontal lines, right? They're both horizontal lines. One's going to cross at 3, the other's going to cross at 5. They're never going to touch. So are these parallel? Yes. And the proof, they are both horizontal lines. That means they share the same slope. Do you remember the slope of a horizontal line? It is 0. Slope equals 0. All right, for letter B, I tell you that y equals 0 and x equals 0. Well, y is a horizontal line, x is a vertical line. Those definitely cross. So are those parallel? No. Y equals 0 has a slope of 0. And x equals 0 has an undefined slope. So undefined and 0 are not the same, and you have to have the same slope in order for them to be parallel. For letter C, I have x equals -4 and x equals -1. That means these are 2 vertical lines, and I did tell you that 2 vertical lines, as long as they're not the same exact vertical line, are parallel. So we're going to say yes. And the rationale, the proof, they are both vertical lines. And even though their slope's undefined, they both have an undefined slope. So I'm just going to write slope equals undefined. So that's parallel. Parallel lines, same slope. In a nutshell, that's what it is. Now, this other topic of perpendicular. So this is a little bit different. And it's probably been a while since you've talked about perpendicular lines, is my guess. So basically, perpendicular lines are lines that when they cross, they make 90-degree angles. You end up with 4 of them. So wherever they cross, 4 90-degree angles. 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. So the way that we can tell that lines are perpendicular, when you find their slopes and multiply them together, you'll get the result of -1, always, always. So I'll refer to that in later lessons as opposite reciprocals of one another. So again, we have a lovely little picture here, and I ask you in this picture, which lines are perpendicular to one another? I'm hoping that you're seeing that we're going to be comparing this one, and I forgot to throw the 3 on there. Let me do that. So we're going to be comparing the 1 and the 3 and the 2 and the 3, because 1 and 2, those obviously are not going to be perpendicular. They're not going to be able to cross to make a 90-degree angle. So in order to figure out if these are perpendicular, I can't just look at it and say, oh, that looks like a 90-degree angle, or that looks like a 90-degree angle. We actually need to prove it. We prove it by finding the slopes, multiplying them together to see if we get a result of -1. So take a look. Let's find the slope of line number 1 first. I'm going to start down here, and we'd have to go up 1, 2, 3, 4, 5, 6, and right 1. So the slope of 1 is 6. And the slope of line 2, to get from point to point, I go up 1, 2, 3, 4, 5, and right 1. That means the slope of line 2 is 5. Let's find the slope of line 3. I'll start from here and go to here. It doesn't matter. We learned that in lesson 1. I'm going to go down 1 and right 1, 2, 3, 4, 5, 6. So that would make this -1, 6 for the slope of that. All right, I'm guessing that you know that if I take -1, 6 and multiply it by 5, I'm not going to get a product of -1. So just to show you how this works, using line 1 and line 3, the slope of line 1 we said was 6, right? I'm going to call that 6 over 1 because I'm going to be multiplying fractions here. The slope of line 3 is -1, 6. When you multiply them together, 6 times -1 is -6, 1 times 6 is 6, and -6 divided by a +6 is -1. So the slope of line 1 and the slope of line 3, when multiplied together, give you a product of -1. There's the proof. So I'm going to write lines 1 and 3. Voila. Okay, now again with just the words, and I want you to have this whole vertical horizontal thing down. I ask, are the given lines perpendicular? And please justify your answers. I have an x equals -2 and a y equals 8. Remember, x equals -2 is going to be a vertical line. Y equals 8 is going to be a horizontal line. When a vertical line and a horizontal line cross, they do form 1, 2, 3, 4 90-degree angles. So the answer to this, are these perpendicular? Yes. X equals -2 is vertical, and y equals 8 is horizontal. For letter B, I have an x equals -8 and an x equals 7. Both of these are going to end up being vertical lines. 2 vertical lines can never cross. So I'm going to say no, they are not perpendicular. They're actually parallel. So no, they are both vertical lines. And finally, letter C, I have y equals 0. So that might look something like this. And x equals 0 might look something like that. Oop, 4 90-degree angles. So I'm going to say yes, y equals 0 is a vertical line. Oop. And x equals 0 is a horizontal line. All right, we will definitely do more practice with this during class. I will see you tomorrow.